A very warm welcome to Tanya Shapiro, who will be leading this webinar and who will be taking you through the amazing visualizations that you can do in R. And you're all encouraged to share your graphs that you come up at the end of the coding session using the Tidy Tuesday hashtag, and tag us at Women Who Code on Twitter and Women Who Code on Instagram to get a shout out from us. And you can also tag Tanya as well. Hope you have a wonderful learning experience today. Over to you, Tanya.
Thank you, Mansi, for the warm welcome. I'm super excited to code with our new data friends today. I'm going to open it up real quick with a presentation. I promise it's not slide heavy. We're going to get right into coding. So just a moment while I figure out logistics for sharing my screen. All right. Share. All right. I don't know who else loves PowerPoint. Okay. All right. Welcome, folks. We're going to be doing data storytelling in R today. Big shout out to Women Who Code Data Science for putting together this event with me. Real quick, just a little bit about me. So my name's Tanya Shapiro. If you're on Twitter, you can find me at Tanya_Shapiro. I post a lot of different things about data and data visualization. I'm obsessed with data viz. A little bit about me. So I started off as a data analyst about 5 years ago. And like many new data analysts, my first love was with Excel. I know. Excel is, when you're used to coding things, you think, wow, Excel was forever ago. And I started dabbling with R because I found an awesome online community. There's R4DS online learning, and there's R ladies. And it's just amazing how many people are sharing their code online. So even if you don't have a data science background, it's really easy for people to learn and share things with such an awesome community. I've been doing various different data things for the past 5 years, specifically in the insurance world. And again, thanks to Women Who Code Data Science, we're putting together this data viz workshop for all of you. So quick overview of what we're going to be covering today. So by the end of today's session, we're going to be producing 2 different data visualizations in R using tidyverse libraries. Before we even get into data visualization, though, we're going to be doing a lot of data wrangling, data cleaning. As some of you are familiar, I'd say 80% of data visualization is actually spent with scrubbing the data beforehand. So we're going to be working with libraries that are specific to that. Then we're going to segue into creating a couple of different charts. We'll learn a little bit about how to annotate charts and also spruce it up with your own custom theme at the end. All right, so one of my favorite analogies for data visualization is actually a cooking analogy. And I'll preface this, I can't cook for my life, so I don't know why I come back to this one, but I think it's fitting. So just like in cooking, there's really 3 stages to this, where the first part is you're procuring your ingredients. Lucky for us today, we're going to be using a data set that comes directly from Tidy Tuesday. A little bit about Tidy Tuesday. Tidy Tuesday is an event that's hosted by R4DS Online Learning. They post a different data set every week, and they welcome everybody to participate, try out a new chart, share their code online, and it's a really cool experience. And it's honestly the way that I learned how to do R visualizations. The next phase, we're going to get into preparing the ingredients. So it's the potato peeling, it's the mise en place, and we're going to be doing that with a tidyverse library called dplyr. For those of you who are familiar with Python, it's a little bit like pandas, where we're going to be reshaping and transforming the data. And then at the end is the exciting, sexy part of data visualization, or what I call the cooking. And we're going to be doing that with another tidyverse library called ggplot. So quick overview, and don't worry, you don't have to soak all of this in. I just wanted to give you a quick exposure to ggplot concepts. The biggest thing that I want you to take away about ggplot is that there's different layers to it. So as we're going through our data visualization, we're going to continue to build on plots. And the way that we build on it in this coding language is actually with this plus sign. So you're going to see a lot of plus signs as we layer different pieces of ggplot together. Some very basic concepts. In ggplot, we have a function called AES, which is how we set up our aesthetics. So think about setting your x-axis, your y variable, your color, your fill, sometimes shapes and sizes. There's a whole bunch of different things you can tweak with aesthetic. And then you have the concept of geoms. And geoms is going to help us specify what kind of plot type we want. So if we're working with a bar plot or a scatter plot, we're going to be using different geoms functions to specify the type of plot we're working with. We'll work a little bit with scales today. Think of scales as a way to customize different parts of the plot. So whether it's your x-axis, your y-axis, your colors, your fills, we can do that with scales and the different arguments within. My favorite part about ggplot2 is labeling. I think that labeling is super intuitive with this because we have one function called labs where we can set up all the different labels for our plot. And then last but not least, the icing on the cake is working with themes. So you're going to be seeing themes towards the end of our plots where we can start specifying what fonts we want, what kind of colors we want, the background of our plot. There's so many different things we can cover with themes. All righty. That being said, let's get down to business. I'm sure that one's going to get some eye rolls here. So excuse me, there's definitely going to be some silly puns as we go through. So I want us to toggle over to RStudio. I'm going to close my screen out while I open this up. And I invite all of you to open up RStudio. If you have any issues opening up RStudio, please feel free to chat our moderators in the chat. And they will be there to help us throughout. So let me go ahead and stop sharing my screen for a moment. All righty. So we're going to go ahead and open up RStudio. And when you open it up, you probably won't see this file first. I encourage you all to download the file. I believe our moderators have put the link out. It is in a Google Drive, so go ahead and download that to your computer. And once you've downloaded it to your computer and you've opened up RStudio, one way that you can open the file is by clicking on the top panel and go to Open File. And then you can browse for it in your directory. So if you have it saved to desktop, you can go to desktop and then click on the file and click open. I want to preface for beginners today, if this is your first time in R, I'm very excited. There's so much for us to cover today, but don't feel overwhelmed. If you prefer to take a back seat and you're saying, Tanya, it's too late for me to do all of this typing, that's perfectly fine. We'll be highlighting code and discussing it together as we progress through the workbook. All right. Okay, so I'm going to give people a few seconds to open the workbook. Now, when you open R, the first thing that I want to cover is what we are actually seeing in RStudio. So we should be seeing 4 different windows or panes. Oh, awesome. I got a thumbs up. I've got people who are able to open it. Would definitely suggest if you can open it, just give me a thumbs up so I know we're all on the same page. Cool. So we've got 4 different panes. The first pane that we have is the source code. So we're going to be working a lot in this pane here, where we'll be running and typing the code here. You'll notice in the bottom left-hand corner, you have the console. So once we run the code, it's going to be sending it here, and this is where it's going to be evaluating our code. In the top right-hand corner, you have your environment and your history here. This is where we're going to be seeing our different variables and data objects stored here. It's nice, so as we start using different data objects, we can preview them here. And then finally, in the bottom right-hand corner, you have plots, files, and packages. So once we start rendering our plots, you're going to be able to preview it here on this part of the screen. The other thing, if you toggle over to your tab Packages, you can actually see a list of all the different libraries you've installed. If you're new, you're probably going to see the first few libraries that you've installed for this workshop. If you're a frequent R user, you probably have a lot of different libraries like I do. And the part that I love about this is I not only get to see all the libraries that I've installed, but I also see the different version numbers. So if there's any version issues, you can always toggle over here to take a peek. If you haven't installed the libraries or packages yet, don't worry, it's not going to take too much time. I have some functions here at the top to help us get started. So we're going to use a function called install.packages, and then you're going to list your library name, and then you're going to run it. Now, the way that we run code, there's a couple of ways we can do it. You can either highlight the piece of code and click run over here, or if you're a Mac user, like I am, you can hit Command Enter. I think on Windows, it's Control Enter, but don't quote me. I'm sure if you hover over the button, you'll see the notes for the shortcuts or the hotkeys. And you're just going to run install. Now, if you've already installed it prior to the workshop, you don't have to do this step. I'm going to give folks a second to get set up with these packages in case they haven't installed them. And while those are installing, I'm just going to cover real high level what these libraries are and what we're going to be using them to do today in this workshop. So the first library that we have is Tidyverse. And Tidyverse is actually a package of packages. You have dplyr in there, you have ggplot in there, and you've got a few others that are really useful when it comes to analyzing data, manipulating data, and so forth. If you already have the library installed, I don't believe it will shoot out an error, but I recommend skipping this step if you already have the library. Don't worry. We're going to import the library instead using this library function. So if you follow along, let's go ahead and just import this. If you're still installing, don't worry, you'll have plenty of time. So we're going to go ahead, you're going to highlight all of these libraries, and then you can click run. So now you can see once we've sent this code, stuff is happening over here in our console. We can see that it's loading libraries. Under Tidyverse, it's going to say, by the way, we're attaching all of these other packages. So you're going to see ggplot and dplyr, which are the main libraries we're using in today's session. And if there's any dependencies for libraries, R is really good at bringing in the other libraries that you'll need. So I think that's the one advantage I've seen when I work with Python and Jupyter Notebook. Sometimes I have to remember what all the dependencies are, but R will take care of that for us. Another way that you can install libraries, if you prefer using the UI, you can actually search for libraries using the install tool right here. And you can type in the library if it's on the CRAN repository. So if you want to do it this way, you can do it individually. Otherwise, you could just stick to the function and run this section of code. All right. So Tidyverse has dplyr, which we're going to use for data manipulation today, and ggplot, which we're going to be using for data visualization. Tidytext is another supporting library that we're going to use to reorder one of our plots. These two libraries here, sysfonts and showtext, these are just purely for our own aesthetic purposes. I know on different computers we have different font libraries. So to make sure that we're all using the same font and there's no issues with who has what font downloaded locally, we're going to be using these libraries to pick a specific font. We have library Viridis. Some of you might be already familiar with Viridis. It has a bunch of different color palettes that are color friendly for us to use. And then finally, we have ggridges. And I like to think of ggridges as it is an extension package of ggplot. So for all of my video gamers out there, I'm going to pick on The Sims. I love playing The Sims. So you might have like The Sims installed, and then you have the extension or expansion packs that go along with it for like tiny homes that give you more options to do things. ggridges is similar in the sense that it has a few more geoms for us to play around with. And there's a bunch of different ggplot extensions that have been created by different authors that let us do more things with ggplot. Like there's gganimate, there's ggtext, there's ggrepl, there's a whole bunch. But for today's purpose, since we're playing around with density plots for the second visualization, we're going to be using ggridges. All right. So after you've imported your libraries, we're going to move on real quick to loading our data set. So I want to first start off by pointing out this arrow. So this arrow symbol is what allows us to set up different variables or different data objects. So what we're doing is we're saving things to a variable for us to use later on. So we're going to be importing our data set that comes from Tidy Tuesday. There is a link here. If you want to use this function read CSV, it's a CSV file. You can actually use either your local file path from your computer, or you can plug in a URL to load in and read data sets. So we're going to go in, and instead of highlighting all of this, if you want, you can just put your mouse towards the end of the line of code and you can hit run. Or if you're on a Mac computer, you can do Command Enter. And now we can see in our console, it's going to load our data frame. I've been super inventive with calling our data frame DF. For those of you who are new to coding, DF is often shorthand for data frame. I'm going to give folks a couple of seconds to load it in. If I could maybe get a couple of thumbs up just to see if people have loaded in the data set, we'll go ahead and proceed, or just say like an okay or I got it. And once you've looked, oh, awesome. You guys with the thumbs up, you're really the true MVPs today. So once you have the data frame, there's a couple of ways that we can preview our data frame in R. One is by using a function called view. So we're going to say view, and then in parentheses, you're going to plug in df, and you can hit run. You know, what this should do is it should open up a new tab in the upper right-hand pane. Sorry, left. I can't tell left from right sometimes. It's a little concerning. And now we can preview our data set. So we can see all the columns. If we keep scrolling, we can see the different records. Another way, if you prefer using the UI, you can also now go into your environment with data frame, and you can click DF, double click, and it'll do the same thing. It'll pop up a tab with your data set. Another cool thing you can do in your environment pane, if you want to see all the different data types that you're working with, you can click on this blue arrow here to expand it, and it'll show you all of the different column names or variables that we can work with, along with the data type it is. So here we see ID is numeric. We can see name is character. We have sex as a character, age is numeric, and so forth. All right, so now we've got our data set loaded. I want to spend a couple of seconds going through it just for us to understand what data we're working with today. So this data set was wrangled by someone who contributed to the R Tidy Tuesday event. I believe it's a data set from 2021, don't quote me on that. And it contains data for all different Olympic athletes at different points in time for different events. If you want to check out the page for it, there's a Tidy Tuesday link that we'll be sending out where you can actually see the page for it. There's a little README along with a data dictionary. So each record represents an athlete for a point in time. We notice that we've got some variables that describe the athlete. So an ID that's unique to the athlete, followed by the name, followed by sex, age, height, and weight, along with some information about the team that they participated on, information about the Olympics itself, what year, what season, where it was hosted, and then some information about the sporting events. And then of course, what would this data set be without a medal indicator, whether or not they received a gold, bronze, silver, or no medal, which is denoted here by NA. And we'll actually see that, like most data sets in the real world, we don't have all of the data perfectly formatted. We have missing values that we're going to handle with. So this is a great example for us to dig into today, especially with dplyr. All right. So now that we have the data set up, I want us to play around and just kind of like warm up our typing here a little bit. We're not going to do a lot of typing, but I encourage us just to test out using R, especially for first-time people in RStudio. So if you want to run function some math problems you can as well. So you can say like 1 + 1, and when you hit run, you'll notice that it's going to pop up the answer here in your console. When the code is finished running, you're going to see this little arrow thing which says it's done running something. If you want to set up new variables, you can set up new variables. And I was told I cannot use hello world for today. I got to be more inventive. So because I watch a lot of RuPaul's Drag Race, we're going to say, yes, queen, feel free to use whatever string you prefer. And when you hit run, you can see it's done running. And now you have a variable here in your environment called X, and it's storing this string. And the way that we store strings is with, you can either use double quotes or single quotes. You can also run things directly in your console if you prefer, but I recommend, if you want to have a running history of what you've done, to use your source pane up here. Great. Okay, so we're going to go over one step before we get into dplyr. And this is going to use our sysfonts and show text library. I just want us to set it and forget it right here. This is going to import a different font library for us using this font add Google function. And I want us to go ahead and highlight both of these rows and hit run. So quick note on this font Chivo for the 538 Nate Silver fans. Chivo is a font that's often used in their graphics. For today, when we're setting up our theme, we're going to be going for a little bit of a 538 feel. There's different fonts that you can use, of course, both on your local computer. I believe this one also has Roboto on here and a couple of others, but for today, we're going to be using Chivo. Now that we've set it up, we're going to get to the fun part. So this is the potato peeling part of it, where we're going to be taking our data and doing something with it. We're going to be shaping it the way that we want for a data visualization down the line. But let's get used to a couple of basic dplyr functions. And I have a cheat sheet here in the pseudocode. By the way, pseudocode is going to be always written with a hashtag in front. So if you want to continue to add comments for your own benefit to refer to down the line, you can always continue by saying, add some comments here. And it'll store that as like a reference note for you in the future. All right, so with dplyr, there's a couple of functions we're going to go over. There's a ton of them that you can explore with different functions within. And here's a link to the PDF cheat sheet. I believe our amazing moderators already have a link out for you if you want to refer to that after the workshop. But one of the most common things that I do with data is I filter it. So we might want to filter our data to see specific records. And the way that we're going to set this up, I want to introduce us to this piping operator in R. This piping operator is going to let us chain different arguments together for dplyr. So we're going to start off by specifying our data frame. So we've saved data frame as df. And we're going to use this piping operator to then say, all right, I want to do something with it. I want to filter my data. So we're going to say df, and I will type this for the first time with you, filter. And then we're going to set our column name that we want to filter on first. So in this case, if I only want to see records for sporting events that are related to swimming, I'm going to set it as equal to swimming. When you go ahead and run this, I don't think you can see it collapsed in my view. I'd have to go out one. But in your console, you're going to see that it's going to run a preview of the data frame. And you should see on your screen, I apologize, we don't see it on my screen, a sport column, and it should just say swimming. And if you wanted to say, I don't want to see swimming events, we can then negate this argument by saying exclamation mark equals sign, saying I don't want to see swimming. Great, there we go. Now I can see the sporting events, so I can see it's just swimming events. Now, oftentimes we probably have different criteria that we want to filter on. So let's go through an example where we're going to filter our Olympic athletes data frame set to see just swimming events. We want to use a filter on year. And I'm only interested in the athletes that actually won something. I don't care about the rest. So we're going to combine all of this together. We're going to use the same filter function. We're going to set up sport is equal to swimming, just like our first one. And then to continue adding criteria, we're going to use ampersand as and. So go ahead and type in and, or you don't even have to type again if you're not feeling up to typing today, no worries. And because year is a numeric, we can actually use a greater than operator. You can use less than. We can use the same kind of numeric evaluators that you would in Excel or in SQL. But for this example, let's go ahead and say greater than 1948. And now I'm going to introduce you to another concept in R called lists. So in Python, I think the way you write lists is right with your brackets, and you can say apple, orange, etc. In R, the way that we're going to write lists is actually by wrapping it in parentheses followed by a C to combine all the elements together. So again, you can either use double quotes or single quotes. You could say apple, orange. And you could then store this, again, with the arrow symbol to a new variable and call it produce. And that'll now create a list. And we can see it in our values. And we've got 2 items in this list. So for filtering purposes, we're going to create a list that has all the different metal types. So you're going to put in gold, silver, and bronze. And we're going to use this percentage in percentage. For those of you with some SQL background, this should look really familiar. It works the same way where it's saying if metal is one of these things in the list, return the value. So we're going to go ahead and run this code. Now, when you preview the data in your console, you'll notice that it's only sports swimming, metals, there's no NAs. I'm now getting bronze, gold, and silver. Great. So that's high level how we use filters with dplyr. So when you want to look at specific records, filter is a good way to grab the records you need for your data frame. Next, we have mutate. So mutate will allow us to add or create new columns to our data frame. So let's say, for instance, taking a look at our data set, we have age for athletes at a point in time, and we have the year for that event. Now, let's say we want to add the year of birth, and I apologize, some of my naming conventions might not be the most intuitive. I used athlete_DOB, but it's really a year that we're using. So we're going to set this up the same way with this piping operator. We're saying, all right, our data frame, let's go ahead and do something with this. We're going to call mutate. And the first thing that you're going to put into mutate is the name of the new column you're creating. So in this case, we're using athlete_DOB. And now you're going to set up the function of how you're going to calculate athlete DOB. And within mutate, there's a couple of different things you can do, but for now, let's just set it up where it's year minus age. Go ahead and either highlight it or leave your cursor at the end and hit run. Apologize, I haven't zoomed out, but let's just look at a sample of this. If I want to set this as sample. I now open up my data set and I scroll all the way to the end. I'm going to see I have athlete DOB. Okay, so we've covered filtering, so specifying specific records in our data set. We've gone over real quick mutate, or how to add new columns. Now we're going to go over how to aggregate data. And with aggregating data, I think it's super intuitive with dplyr. We've got a function called group by. Again, if you are a Python lover, this is going to look a little bit familiar to pandas group by. I confuse group by underscore with pandas one word group by. That tends to happen if you're switching code languages. And we're going to couple it with another function called summarize. So within df, so let's back up. Let's say now we have our data set with all of our different athletes, but I want to just take a quick look at how many athletes I have based on sex. And I want to also figure out like the median age for each based on sex. So to aggregate it based on a variable, we're going to first use group by. So we're using our piping operator here, starting with group by, and you're going to plug in the variable that you're grouping on. So in this case, we're using sex. The next step that we're going to use is summarize function. And the summarize is where we're going to specify how to aggregate our data. And if you reference back at the dplyr cheat sheet later on, you're going to notice there's a bunch of different aggregation functions you can use. For the purpose of this workshop, we're only going to be covering a few, but there's a lot of them that you can play around with. So for athletes, what we really want to do with our data set is get a count unique or a count distinct of everything. Because if we notice going back to our data set, we have athletes repeating. So doing a plain count isn't really going to give us a count of athletes. It's going to give us a count of athletes for specific events. So the unique identifier here that we have for athlete is ID. So we'll leverage this for our count distinct. Now we're going to plug in the name of the new column that we're creating. So athletes. And we're going to set it up where you have an equal sign and plug in the function for your count distinct. So the function for count distinct here in dplyr will be n_distinct. Now, if we wanted to just do a count of all the records, there's another function just called n. You don't have to overwrite this code by any means. But for today, we want to get a unique count of everything. So we're going to say n distinct, and then we're going to plug in ID. Now, let's say you want to add more variables than one in summarize. You can continue to add new variables by using a comma delimiter to keep building on things. So let's set up median age. So we're going to say median age. By the way, I'm a big fan of snake case, if you couldn't tell. So a lot of things are going to have underscores to not be too redundant. I'm just going to pronounce the variable name without the underscore. Is equal to, and now we have a new function called median. This is another aggregation function that we can use. So we're going to plug in age and median. And first I want to run it without using the second argument that I have in median. And I want to see what happens. So if we run this, you're going to now see your data that's aggregated by sex. You have number of female athletes and number of male athletes. Definitely not proportionate at all. I don't know the history of the Olympics, but I'm sure there was probably a point in time where women started competing later than men. And you also have median age, and you'll notice that median age now has NA. Why do we have NA? Well, let's go back to our data set. If you look at our data, some columns we have NA values or we have missing values. So if you're starting to aggregate things with functions like median and your column contains an NA, it's going to default that to NA. So what we want to do, if you don't filter out NAs up front, we can specify within the function to ignore NA records. And the way that we're going to do this is we're going to add a comma, and there's an argument called na.rm, short for remove NA, and it's a Boolean argument. So we're going to set this to true. Now, what this is doing is telling the function, just go ahead and ignore the NA records and only calculate the median on data that's available. Now, when we run it, we can see great. It's calculating median age. For female, we see 23, and for male, we see 25. Okay. Now, for the sake of brevity, I've put a lot of this on one line. Typically, when writing code, it's easier to break it up on different lines. So I want us to go ahead and practice writing code with dplyr. So we're going to start off by calling our data frame variable df, and we're going to do that percentage greater than percentage operator. Now I want you all to click hit return. The nice thing about R is that it does the formatting for you up front. So it does that nice indentation for us. And you can start building, let's say filter. We're going to keep it the same like our previous example. Sport is equal to, and then you're going to type in your string, swimming. Now we can continue to add different dplyr functions together by piping it with that operator. So we're going to say percentage. We're going to go on the new line, press return. You can add the mutate on this line. Let's say athlete underscore DOB, year minus age. And we're going to keep building. Now we want to group by. So let's say I want to calculate the number of athletes based on your birth. And we're going to couple that group by again with our summarize function that lets us aggregate data. And we're using that n distinct based on ID to get a unique count of IDs. Now there's one more dplyr function I want to introduce us to, and it's arrange. So if I run it just like this, I highlight the section of code and click run. I'll notice that it's in no particular order. So if we wanted to sort this, we can use another dplyr function called arrange. Oops. I don't know if you've got lazy typers that copy paste code a lot, but I've done that in the past. So feel free to do that as well as you're following along. And then we can say athletes. And I'm putting a negative, I'm negating athletes, so it sorts it in descending order. If I remove this, it's going to sort it in ascending order. So now I can see it in ascending order. By the way, shout out to our moderators who are fielding questions in the chat. If you have any questions while we're going through this, please feel free to send them a note and they'll be happy to help you out. We'll also save some time for questions after our first visualization and towards the end. Okay. I know we're itching to get to the data visualization part, but I couldn't resist showing some things in dplyr. It's one of my favorite libraries to use and makes data manipulation really easy. So moving on to our first plot, we're going to start off with a bar plot to do a comparison. We're going to compare the top teams overall for each swimming style based on number of medals. Now, in retrospect, given NCAA March Madness, I probably should have done something with basketball, but at the time I picked something with swimming. And for those of you who know nothing about swimming, that's perfectly okay. All you need to know is that in swimming, there's different styles for it. So you've got freestyle, you've got backstroke, you've got breaststroke, and we're going to be analyzing data based on the event of the sport. Okay, so I have a lot of it commented with pseudocode here. So don't worry, if this is a lot to take in, feel free to come back and reference this. So we're going to start off with df. We're going to filter. We're going to use pretty much the same filter that we did in the first example. And I don't want you to feel overwhelmed by this function here. I'm using grepl here to remove a sporting event that contains the word open water. So if you're dealing with a lot of not standardized text, for instance, you might have gold medal 1, gold medal 2, and you only want to see the records that have gold. grepl is a great function to explore, but we're not going to go too in depth for during this workshop. All you need to know is that we are removing any event that contains the phrase open water. And then we're going to go into our mutate function. A lot of this part we're actually just reviewing together. We're not running the code until the end for the sake of time. And in our mutate function, we're going to be setting up two new variables. And I want us to take a quick look at data frames. So if you go and pull up that data frame tab again, there's one way that we can filter and preview the data frame just to see swimming events. If you look at the upper right-hand corner here, you've got this search bar. Go ahead and type in swimming. And because our data frame is rather large, there's almost 300,000 records, it might take a second to filter out and find all of the records that have swimming somewhere in a column name. If you want to do just a quick preview in the UI, this is one way you can do it. So now it's pulled up only the records that contain swimming. And if you go ahead and take a look at the event names, you have swimming men's 400 meters freestyle. If you keep scrolling, you'll see women's. So if you only want to get this part of the text, freestyle or breaststroke, we're going to have to do a little bit of text handling, which is great. I don't know how many of you deal with perfect data sets in your careers. If you are, I am super jealous. I constantly live and deal with dirty data. So this is a great example for us to play around with text data and create new columns based on what we need for our data viz. So the assignment here with our mutate is we want to take this event column. We want to just strip it to see freestyle, breaststroke, or swimming style. We don't care about the rest of this text. In fact, we also want to standardize it because some text contains swimming men's and some text contains swimming women's. So the first step will be removing that first chunk of text just to reveal the meters and the style. And how we can do that is we can use a function called str_replace or string replace. This is a function that is part of a different library in tidyverse called stringer. And what you need to know for string replace is that it takes in 3 different arguments. So the first thing that we're going to pass into it is the name of the variable that we're doing something with. The next argument is the piece of text that we want to replace, followed by what we're replacing it with. So we're just replacing it with an empty string to get rid of it. And to get a little bit more complex, since we're working with swimming women's and swimming men's, to specify different text, so it has to meet one criteria or the other, we can use this pipe to separate it. So now the code is just going to look for swimming men's or swimming women's, and it's going to replace it with an empty string. I know this is going to be a lot to take in, but I'm giving a flavor of different things within dplyr and tidyverse. You can always come back to it and play around with it later. Another way of dealing with some text handling, I couldn't resist using case when. So along with Excel, SQL was my first love. I love SQL. So when I found out about case when, I got really excited. I don't know how many SQL people we have on the line. For those of you who are not familiar with case when, it's a basic if-then function. So all we're doing is saying, if something meets this criteria, return this value. If this, return another value, or if none of these criteria apply, return this. So within case when, we're going to plug in our first set of criteria. So if you remember from our first introduction with dplyr, we were using lists. If you spend a second to go into the data frame on teams, you'll notice that at different points in time, you might have different team names for country. So it's not a great proxy for country. Actually, during one part of the Olympics, you had an East Germany team and a West Germany team. For the sake of this visualization and tutorial, we're going to be converting anything that says East Germany or West Germany to just say Germany. So we're going to say if team is in, we're going to specify our list. It's either East or West. We're going to use this squiggle. I know it's officially called a squiggle. I think the real term is actually a tilde, but I'm just going to call it a squiggle symbol. We're going to return Germany. And then the way that we say if not, or our other bucket, we're going to say true tilde and return the variable if it doesn't meet that criteria. So in this case, we want to just keep the team name. So in mutate, we are overriding our variables by cleaning it up both with string replace, and we're using a case one. Okay. So if I was to highlight this code, I can actually highlight a chunk of my code and just run it. It'll pull this up. This isn't the best preview down here, but I'm just making sure that it is now cleaning up the text. So I can see there's no more swimming men's and swimming women's. Now that we have it cleaned up, the next part of this is going to be splitting it out. So we have a new column with just the style. Because now if we take a look at it, we're going to get something like 400 meters freestyle. By the way, I think, I don't know if we've got anybody from the UK on the line, but is this the British version of spelling meters? Because I noticed that in the data set. It's definitely not the way that I spell meters. So in our next part of our data transformation, we're going to be using a function called separate. And separate is a nice function to use if you want to take a column and split it into 2 columns or potentially more than 2 columns. And the arguments that we're going to pass into separate is first the variable that we're manipulating. So in this case, event. The next argument is going to be specifying what new variables we're creating. And we specify that as a list with the strings as the new column names. And lastly, we're going to be saying what we're splitting it on. Now, in most cases, you're working with like comma delimiters, so you would just put a comma here. But since this is a really unique case, we're going to be using meters with space around it as our delimiter to break it out into 2 new columns. I'm actually going to just hit enter for a second. You don't have to break up the code, but I want to give a quick sample of what that looks like. So if I run this separate without the additional pipe, it's going to create a new variable called swimming. And I'm just spot checking to make sure it's doing what we want it to do. So now if you scroll over, you can see it is split out event. We no longer have that event column. We now have 2 new columns, one that has meters, the other one that has style. Okay. One more step with this complex data transformation. There's a lot on here that you can revisit after. We're going to aggregate our data now based on team and that new variable that we set up, which is style. Because the prompt is we want to know what are the top teams per swimming style. We're going to follow that by a summarize argument here. We're using that n parentheses function just to do a quick count. And then I've included an arrange just to see it in descending order. Go ahead and click run, highlight the entire code. So now in your environment, you should see swimming with 159 observations and 3 variables. Go ahead and give me a thumbs up if you can see that. Better yet, why don't we go ahead and click on swimming. Awesome, you guys with the thumbs up really rock. Great, so we now have team, style, and medals. There's one last step, which is getting the top teams based on style. So we're now saying I want to get the top 5 or the top 8 per swimming style. And I don't use this one often, but for certain use cases, you might find it useful in the future. We're going to use another group by, and we're going to use an operator called slice max. But the first thing that you'll notice in this code is we're filtering out anything that says relay. We're going to keep it really specific to just swimming styles for individual styles. We're removing anything that says relay with REPL again. We're going to group by style. And now we're using a new function called slice_max. And what we're saying here is I want to order it by medals descending. And here's the count of records that I want to return back for that group. So when we run this, it's going to filter it out just to see my top teams based on style. Go ahead and highlight that code and click run. Now you should see 42 observations and 3 variables. Quick side note, if there's some ties between different teams, like let's say there's you have 3 teams towards the end, you might have more than 8 per grouping, but for the sake of today's visualization, we don't have to worry about that. One more thing before we get into our first plot. I know we're all itching for the data visualization bit. We're going to just create a subset of the data frame we just created, which is swimming top. And we're going to filter it just to see freestyle, because I want us to start small on our first one. Go ahead and click run. And now you should see we have 1 data frame object listed here with 8 observations. Awesome. Okay. Now the moment we've been waiting for, the data visualization or the cooking part. We have peeled the potatoes. We have our mise en place. We're ready to get cooking.
Tanya,
Yeah.
before we jump into the visualization, we have 3 questions pertaining to data wrangling. If you could take it up.
Yeah, absolutely. Let's go ahead and pause. Good pausing point.
Yeah, the first question is, what can we use the plus sign instead of the percentage, greater than percentage, for concatenating different functions?
So this is the piping operator for dplyr. If you tried using percentage, I don't believe that's going to work. It might give an error. So here you can, in the console, it's going to give you an error message. So depending on package, you're going to find out that there's different syntax, different styles for how things are chained together. This plus sign, we're gonna get to it for ggplot. Great question. That's how we're going to layer ggplot. But in terms of chaining all your functions together, you're always going to use this piping operator. I believe there was a shortcut in the chat, Mansi, of how to do that with hotkeys.
Yes.
Okay. All right. Do we have any other questions on data wrangling?
Yeah. One is, what does percentage in percentage do?
This is what we call a piping operator. So it is saying, all right, with our data, let's do something.
No. Percentage in percentage. I think.
Yep.
Yeah.
Great. Okay. So this percentage in percentage is it is filtering through a list. So it's saying if metal is in this list, if it's one of these items, go ahead and bring in the record. So instead of having to say metal is gold or silver or bronze, all we're saying is metal is in this list, and it'll pull back all of those records. Great question.
All right, and the last one is, do you ever use data.table instead of dplyr? And what is your take on the data table versus dplyr debate?
Ooh, we have an efficient R user on the line. I will be the first to admit that I'm not as familiar with data.table. I've relied on dplyr a lot for wrangling, but I hear a lot of great things with data.table. So I'm going to sit this debate out, and I don't really have an opinion, sorry.
All right. Thank you for the nice questions, everyone. And thank you, Tanya. And let's get started with the visualization part.
Awesome. Thanks, Mansi. Thanks all. So we have our data set up. The first thing that we're going to do now is start by writing our first ever, well, for some of us, it'll be our first ever ggplot. For others, might be the 100th time, 200th time, but it's always exciting creating a ggplot together. This is my first time, by the way, coding with data friends together, so I'm excited. So the first thing that we want to do is start by writing out ggplot. And we'll notice that the first argument that it wants us to pass in is data. So what data are we using to create our first plot? So I'm going to be very specific and write out the arguments and say data equals, and we will specify, we're going to use our freestyle top data frame. The next thing that we can do is set up the mapping. So now we're telling ggplot, I want my X variable to be this and my Y variable to be this, and we're going to set it to the column names within our data frame. So we'll start, and it's AES is the function, and it's short for aesthetic. And we'll say X is equal to metals, Y is equal to team. If you've used matplotlib and Seaborn before in Python, this should be a little bit more intuitive. And it doesn't stop here. So the next thing that we need to do is specify what kind of plot we are creating. So we're going to do that by using that plus sign to keep building. I'm going to hit return. And since it's a bar plot, we can use geom underscore bar. And there's one other additional argument we're going to set, which is going to say stat is equal to identity. If we didn't set stat is equal to identity, it would just count the number of records. We want to specify that metals is actually an aggregation. So let's go ahead and highlight that code and run. Okay. We have officially created our first ggplot together, and you should see it render in that bottom right-hand corner. Go ahead and give me a thumbs up or got it in the chat just to make sure. If you're running into any issues, we have our awesome moderators here to help too. Cool. Great. Getting all the thumbs up. So looking at our first graph, you might say, all right, we have it. I'm not completely in love with it. It's looking pretty monochrome. What are we going to do to spruce this up? Right? I promised you that we would be sprucing up visualizations. So one thing that we might want to do is we might want to add some different colors to it. If you're OCD like me, you want this to be in descending order because the prompt was find the top teams. When you render this plot, it's going to default order it based on your Y variables, which is team. You can see it starts alphabetical order all the way from the bottom to the top. So we'll reorder this based on metal counts in descending order. All right. So first step, let's reorder this to make it a little bit more intuitive for people to look at. So the function that we're going to use within ggplot, we're going to pretty much copy paste the same thing, or you can use the code below. ggplot, we're setting up our data, we're mapping it with aesthetic, we're specifying the geom, which is giving us the bar plot type. We're going to go back to our aesthetics, and within our aesthetic for metals, we can use a function called reorder. So we're going to say reorder. Apologies, it's not the X one that we're reordering, it's the Y. So Y reorder. So we're reordering team, and the next part of it, the next argument followed by a comma, is going to be metals, what we're reordering it by. Okay. Pro tip, if you look at your R panel, if you see like red errors, it actually gives you some hints on what's going on. I've definitely run into this a few times before where I forget to close out a bracket. So here it's prompting me and saying, by the way, we don't have a bracket. I can see that this is the matching bracket for AES. So I'm going to add another one here. And if you highlight the code and click run, it's now going to reorder our plot. And the first comment that I got, I actually tested this out with my partner, and she said, that's a really ugly label. Now there's like an error because I see this reordered team metals. And R is just being really literal with how it's labeling my y-axis because I'm saying reorder. And don't worry about it. We're going to clean this up with another function in just a moment with labels. But it is not an error. I just want to point out that it's just a really messy label based on how we've used this function. Let's go ahead and run this entire piece of code. I'm going to walk through what some of the other arguments and other geoms mean. And if you run the code, I'm actually setting this plot, this entire ggplot, to a new variable called bar. And you'll see it pop up in your global environment up here as bar, and it's storing it as a list. And if I now just run this bar variable, it's going to pull up my plot. So I tweaked a couple of things in the meantime. There's another argument within geom bar called fill. By the way, preface that you can find all of these arguments on the ggplot cheat sheet. I certainly haven't memorized all of them. I am guilty of going back to some cheat sheets every now and then, especially if I'm dealing with new geoms, to understand what all the different aesthetics are that I can tweak. But for geom bar, you have a argument called fill that you can set to a color. And it will either accept a regular color if you type it in, like let's say blue, or a hex code. I can see someone already chatted something to generate hex codes. I love finding specific hex codes. So if you're not in love with this purple, feel free to change it out with a color that suits you. But you can even say, I'm gonna just fill it with blue, and it'll change the color up. I'm not wild about the typed out colors. I love hex codes. So we're gonna just keep it with a hex code. Just keep in mind to always add your hashtag value beforehand. Otherwise you are going to get an error. Or it defaults to a different color here. It's reading it as a string. It's not reading it as a color. Oh, someone has a different shade of blue. I'll go ahead and use that. Oh, that's kind of like Carolina blue, right? I apologize if there's any Duke fans on the line. Actually, I don't apologize. I take that back. I do support UNC tonight. Okay. All right. So we now have the colors changed, but we still have these ugly labels. So we're going to play around with ggplot labs to change up these labels. And I'll code this here from scratch. So we're going to start with bar because this already contains my graph. We're going to keep building on it using that plus sign again. We'll indent. We're going to say labs. Now labs has a couple of different arguments in here for us to tweak: title, our subtitle, our axis labels, and our captions. So if I just said title, freestyle swimming, it'll change this. And by the way, you do not have to type this out. You can also just run this part of the code here. And we can keep going. We can add subtitle, something about freestyle swimming. I think I have more serious titles in the actual example. And then we're going to set our Y to team. You don't have to indent for each one. I just think it's a little more readable, but you can always keep it on the same line too. And now when we run it, we'll notice that it's going to relabel it. And now we have a title, we have a subtitle. We also have a caption here. I like to use captions to give a call out to the source of the data that we're using. Sometimes I also add my name to the bottom. I've left it blank here for all of you to edit and insert your own name here. So you can go ahead and tweak this. Don't type my name, please type your name. And we can run it. I personally like labs because I can just do it all in one function. When I was playing around with matplotlib, I found I had to do a new line specifying different arguments. If you're a Python pro and there's a better way to do it in Matplotlib, please give me a shout out afterwards and let me know. I've been trying to figure out a more intuitive way to edit it, but in ggplot, we can just do it all in labs. Great. So we have our new graphic. Now, the last part that I want to cover for our first plot here is how to tweak the theme. And in ggplot, there's a whole bunch of different things you can do within the theme function. Definitely recommend going through the ggplot documentation to get a sense of all of it. We're going to cover just some very basic ones today. So we're going to be using this theme argument with bar. So again, we're chaining it with the plus sign. And we're using theme. And one of the arguments we're going to pass through is text. So if we want to change the font family of our text, we're going to use this to change it throughout our plot. And we will be using element text function to edit that. So it's going to be text is equal to element text. And then within it, we have a couple of different arguments. You're going to have family, you're going to have face. You even have the colors of the text if you want to change that up as well. But we're going to just plug in the Chivo font that we imported before. And we're also going to modify plot title. So this is going to be plot.title, element text, face. We're going to bold it. So we're going to say face is equal to bold. Let's go ahead and run that all together. By the way, if it doesn't render in your bottom right-hand corner, I recommend either clearing out your plots. Another way, if you want to zoom in on your plot, you can click on this magnifying glass with zoom, and it should pop out your plot. If you don't see it pop up immediately, it might be nested here. So if you click RStudio, plot zoom, now we can see our plot. And the font family should have changed. Hopefully it looks a little bit more like 538. Go ahead and give me a thumbs up or an okay, got it. Let me know that you've successfully rendered your plot. And if you don't, hit up Mansi or one of the moderators to help out. Awesome. I wonder if anybody has specific font preferences for graphs. I definitely have some that I default to. Okay, awesome. Love the thumbs ups. So we're going to build on this bar plot. I call this like chart 1.A. We're going to have 1.B here. And if we recall the original prompt, we actually want to see the top swimming styles, top swimming teams per style. We don't just want to see it for one style. Now you might be groaning and saying, oh God, Tanya, now we got to filter all the data sets. I got to build the plots all over again and probably copy paste to get one for freestyle and one for backstroke and so forth and so forth. I have really good news. In ggplot, there's a really easy way to create multiple plots by faceting it with one line of code called facet wrap. So we're going to go ahead and explore that. Oh, you know what? I apologize, guys. I think I blew over one additional part of this code, which is geom text. So we actually added a text label. You can see that there's counts of metals for each at the very end. And all we did is we added another geom to it. So think of it like that layered cake. Again, I don't know why I come back to cooking analogies. I don't bake and I don't cook, but here I am. And within geom text, all we're doing is we're setting up aesthetics again. So you can either set up your aesthetic in your parent argument here for ggplot, or you can set it up in another geom. And there's a argument for our geom text aesthetic that says what's the label that we're using. So we're just giving it the metal count. And then outside of the aesthetic, we're specifying the color. There's a couple of other things that we can adjust with text, including the size of the text And we can horizontally justify the position of it. So if we want to inch it a little bit over to the right or to the left, we can use this argument to do it. If you're just joining in, don't worry, we're going to be sharing the video for this afterwards, but there should be comments in the code to follow along. So if you want to run the code, I think we're right around line 90. You can go ahead and run it all together and just jump right in. Okay, so back to faceting. Apologize, I went right back to geom text. Did not give geom text any love. We're going to go to faceting. So now we have our standard plot showing top teams, and we want to facet it based on style. I'm actually going to remove the scales argument real quick just to show you what that looks like. So the way that we facet it was we plug in the variable name, but it's followed by that tilde or that squiggle symbol. And instead of using freestyle swimming, we're going to be using that original data set that we created in dplyr called swimming_top. And it's going to have similar aesthetics here. Again, we can set the aesthetics in the geom itself. So here we're just saying y is equal to team, x medals. And you'll notice that fill is different. We're not setting fill to a specific color, but we're actually setting it to a variable name this time. So this is going to say assign a new color for each bar plot based on the style name. Go ahead and run this code. Okay. I'm going to encourage everyone to use that zoom function to pop it out because it might look a little too busy in that small corner of your screen. So now when we pop this out, I can see it's faceted, the plots, but it's not great because I'll notice that some of the bars are blank for certain Y variables. And that's because you have different teams in different categories. What this is doing is it's using the same y-axis and the same x-axis for each and every single plot. So we might want to make them totally independent from one another. So what we can do in facet wrap, if we want to make them independent, is use something called scales. And then you can type in free. So now for each plot, notice that the y-axis and x-axis is specific to each and every single plot. And you can tweak around the scales in facet wrap if you just want it. So it's only the y-axis that's independent. You can note that with free_y or free_x if you're dealing with x. We're going to keep it to free_y. We'll go ahead and run that. Now we can see that the x-axis is consistent for each one. It's going from 0 to 150, but we have different teams for our labels. Go ahead and give me a thumbs up or a creative, you got it, whatever you prefer is easier, just so I know that you're able to see it on your screen, you're following along. Awesome. Okay, so you'll notice that we have a similar issue to our first plot where it's now listing it by team, but it's doing it in alphabetical order. We want this to be in a nice, beautiful descending order. And this one is going to be a little bit more complex to reorder because it's within different groups, but we're going to be able to do this with the tidy text library. I will admit that I found out about this trick not too long ago from an amazing blog post by Julia Selge. I have it in the pseudocode over here. I'm going to pop it in the chat if anybody wants to, if anybody loves reading blogs, this one's a great one to take a look at. And we're going to be going back to reshape our data. So it's important to know that sometimes we've got to identify what's something that we can tweak with ggplot versus what's a data reshaping problem. And this is a data reshaping problem. So we're going to go back, use our handy dandy dplyr to reorder this and couple it with another function from tidytext called reorder with then. We're creating a new data variable called swimming ordered. Go ahead and highlight that and run. So we're using that mutate function to override teams, and we're reordering teams based on metals for each and every single style. Okay. You should see swimming reorder pop up here. Notice that the number of variables has not changed. Okay. And there's one additional thing that we're going to do to make sure that it is now ordered the same way. So we reshaped the data, and we're now going to pair it with, this is the first time we're seeing it, in ggplot, you're going to come across different scale functions that let you tweak things like your y-axis or your color or your fill or shapes and sizes, depending on what aesthetics you're playing with. We're going to go ahead and append that to our original data set. We're storing it into bar facet. So notice everything stays the same. We're now just adding the scale reorder to the end. So go ahead and run that all the way from bar facet to the top. Hit run. I'm going to pop this out in my Zoom view for us to take a look at. Great. And now it is ordered in descending order for each and every single plot. The next phase of this, we're going to just quickly clean this up. A couple of things. So now we notice that the color is set based on style, and it's going to use out of the box colors to set it for each and every single style. I would say this legend is not needed, right? It's kind of redundant. We know that it's a different color for each one. So we're going to go ahead and remove this legend. And we're going to tweak the colors for this using another scale function to use our own custom colors. So taking a look at the code, we're going to build on that bar facet using that plus sign again. And now we're using, if you actually start typing, you can see the different scale options. So you got scale fill bin, scale fill continuous. So if you're setting a color to a continuous variable, you've got to be real specific with mentioning whether it's continuous or if it's if it's discrete. So we're going to use the scale fill manual argument. I'm going to be redundant with typing. And the argument that we're going to adjust, we're going to adjust the colors to our own colors. So we're going to say values. And now the argument values is going to accept a list of colors. And we have a total of 5 different styles. That means we need to pass in a list of 5 different colors. I've gone ahead and picked out some different hex codes in advance. Again, you are welcome to go ahead and customize it and add your own flavor to it by picking out your own colors. And when you run this, it will change it to and map it to these 5 list of hex codes. Plugging in another labs function to set titles, subtitle, captions, and labels. Go ahead and add your own name here in the caption. And I want us to take a second to also explore the theme for this one. So like the last one, we're going to adjust our text so it's only Chivo using element_text. We're going to be specific about bolding our plot title. And if we take a look at the original plot, you'll notice that with each plot you have grid lines, right? And to simplify it, maybe sometimes we want to just remove certain grid lines. You can either remove all grid lines, or you can be specific about removing the minor grid lines. So there's a way for us to do that. And it's panel.grid. And notice that there's so many different specific things you can tweak. You can either remove all the grid lines here. You can play around just with the major ones, minor, or even so specific as major.x, which is just your x grid, major x grid lines, or y. For our plot, we're going to tweak this by removing our minor grid lines. And the way that we can remove it is by using a function called element_blank. It's just going to remove everything for us. A couple of other things in theme that we can work with. So if you notice our facets, each one of them has a header block. The way that we can adjust header blocks is with this, it's called a strip. So we can say strip.background, which will be the header background, and we will use element rect. I assume that stands for rectangle to adjust the fill. I've used gray 20, so you can specify a shade of gray by adding a number to it. You can also make it black if you prefer, or plug in your own hex code. Adjusting the text for each one, since we're now creating a darker shade, I like to go with a lighter color so it's more legible. And then at the very end, we can remove our legend with legend.position. Now there's a couple of different ways you can remove legend, but we're going to play around with this one first. If you wanted to adjust the position of your legend, this sounds redundant, the argument is legend.position. You could say, I want it at the top. You could say, I want it at the bottom, left or right. But because it's a little redundant to have the legend, we're just going to say none to remove it. Now go ahead and run that piece of code. All right. Now we have it with our custom theme with the Chivo font. There's different colors now based on that scale fill. And I noticed that the strip text have been changed. Go ahead and give me a thumbs up or an equivalent if I've got it in the chat to make sure that you're able to see it. Awesome. Awesome, love it. Okay, so we've created our first ggplot. We got a little bit more complex with facets. Facets was mind-blowing for me the first time I saw it. I hope you enjoy faceting as much as I do. The last step for creating this plot is saving it. So to save our plot, we're going to use a function. But before we do that, I want to make sure that we all know how to set our working directories, because when we save this file, it's going to save to whatever directory that we specify as our working directory. So take a moment real quick at the top of your panel here, find session, click on session, and then click on set working directory. And then you're going to click on choose directory. So we can change the directory. If you have a folder that you want to save it in, go ahead and set it to that working directory. For today's workshop, I'm just going to use my desktop. I made sure to clean my desktop in advance because it's normally not so neat. I don't know how many people have crazy desktops with 1,000 files. That is definitely me. And once you set your working directory, I want us to go ahead and save our plot. So we're going to be using the function ggsave. And in ggsave, we want to pass in the name of the plot that we've created. So we stored this in var facet2. We want to save it with a file name. And if you prefer PNG, you can always change the extension of this. It accommodates a couple of different formats. I've set it to JPEG. Then you set your height and your width. Go ahead and run. Once it's done running, you'll see that it ends with this little arrow sign. If you're building a really complex plot, it might take a second to save, but this one seemed to run pretty quickly. And now let's go ahead and open up our directory. So I want you to go ahead and navigate on your computer to the working directory and see if you can now find that new file, top_swimming, or whatever you've called it as. If you've decided to change it to something else, you should now see that file in the directory. Let's go ahead and open it up. And there we have it. So now if you're working on a slide deck, you can plop it in, you can share this. Oftentimes, like if I'm on Twitter, I'll attach my code, and well, I'll have a link for the code and I'll attach the plot as a picture. go ahead and give me another thumbs up or okay if you're able to find your plot in your directory. Awesome. Sweet. All right. So I want to take a beat here. We just created our first plot. Before moving into plot 2, I'd love to open it up to questions if folks have questions. Mansi, you there?
Yes, we have 2 questions. One is how does, so this is a little above in the code, that how does putting medals to reorder in y-axis give us the descending order of countries by default? So is it default? Descending is default and reorder.
Reorder, right, is descending by default. If we had just plugged in team, it's going to, since it's a discrete variable as a string, it's going to sort it based on the name. Now, I recommend if you want to be really specific on how you order things, like let's say you want to put Germany first, United States last, and things in between, I recommend taking a look at how to set up factor variables. We won't cover that in today's workshop, but if you want to be super custom, I recommend using factors.
Great, thank you. And the second one is a little generic. What are the various ways we can create a dashboard with all the visualizations in a browser?
Oh, that's a good question. So there's, I'm only familiar with a couple of different libraries outside of ggplot. One way of creating a dashboard, I've used Shiny in the past, where you can actually pass in different ggplots and put it all together. I welcome other R users. If you've used other dashboard libraries, please send them out in the chat, but Shiny is one of my favorite ones for building dashboards.
Thank you. And we have another question: how to shift the country names from left to right on the y-axis?
On the y-axis, so if you want it on the other end, that's a great question. I don't have the answer for you, but I'm sure there's some arguments in the documentation to explore. I haven't really created one where you've got 2 axes, but there's definitely a way to do it in ggplot.
All right, thank you. And I think, all right, yeah. So these were the questions. If you go, we can move to the second visualization if we don't have any other questions, people.
Yeah, if you need another coffee, my West Coast folks, go ahead and make a coffee. It'd be a great time to maybe pour another glass of wine. For my transatlantic friends, I know we've got a bunch of different time zones on this call, which is really exciting. Okay, we're going to move on to our second plot. We're going to be working with reshaping our data to another data set. And the next chart that we're going to explore is a distribution plot. So there's a couple of different plots where we can view distribution. Histogram is very popular. Another one is a density plot. So for density plots, for those of you who are not familiar, I like to think of it as like a rolling hill, not to be confused with the rolling hills that I do on my Peloton bike, which I really don't love. But we're going to go ahead and set up our first density plot. So first thing we're going to look at is our data set. And the thing that I noticed here in the data set that might be interesting to look at for distribution is height and weight. So you got different heights and different weights for different athletes. Now, I think it's pretty safe to assume that the distributions are going to look radically different for male and female athletes. So we're going to go ahead and filter our data frame just to look at female athletes. And we're going to set this up with filter. And for the sake of time, we won't go through all of this line by line, but what you need to know is that we're going to be aggregating data on the athlete level, because the data set is not specific. Each record is not an athlete. It's an athlete at a specific point in time. So we're going to group by some variables that describe athlete. We're going to summarize our data. Let's go ahead and use the medians. I I know that there's some fluctuation based on different times, but median will suffice for now. We'll use the same thing with na.remove to remove any na values. And if you're an American like me and you're not familiar with the metric system, or it's a little bit different for you to read, you can go ahead and use mutate to do that conversion. So I'm setting weight as kilograms and height as centimeters to be specific. And then at the end, we're going to be using that mutate function to then translate it. If you want to get rid of messy decimals, you can use a round function similar to Python and Excel, and then specify the number of digits that we want to round to. Let's go ahead and run that code. So now we've got it set up as female athletes. You should see that in, oh no, took a second to generate. Great, so now it's done running. We've got almost 30,000 records here in a new data frame called female_athletes. Since there's a lot of different sports and we're going to be creating density plots for each different sport, I've gone ahead and pre-selected and created the list of sports that we're going to be using today. So here's an example of setting a list into a variable. So let's go ahead and run that. So now you have sports. We've got 8 different sports in here, ranging from basketball all the way to gymnastics. And we're going to subset our data. Notice I'm using that in function again. So in percentage, and I'm calling that list specifically instead of putting the list here directly in the filter. It's another way that we can use it. Go ahead and run that line. Now you have a subset of that data. This is where we get real inventive with naming conventions. Fem_ath_sub that has about 10,000 records. Here's where we're going to get into building our geom density plot. So if you recall, when we imported our libraries, there was a library called ggridges. We're going to be using geoms that are specific to ggridges to keep building onto this plot. There's actually more information at this link right here that I have provided in pseudocode. I'm going to chat this out on Zoom to folks. And there's a lot of things we can play around with here. So just like we did before though, we're going to start by saying ggplot. We're going to put in our data. So for this case, it's going to be ath sub. And then we're going to specify our mapping. So for our mapping, we'll set it up where y is equal to sport. X is going to be equal to weights. I apologize to my international friends for sticking with pounds. I can't break the habit of the imperial system here. And for fill, this time we're going to be using a function for fill. So we're going to be passing in stat x. And all you need to know is that this is going to create a nice, pretty gradient along our density plots based on weight. We're going to keep building onto this by now specifying our geom. So if you just imported ggplot or tidyverse, you won't find this geom in the package because it's specific to ggridges. But if you start typing out geom density ridges gradient, you'll see that it's specific to ggridges, and you can click on this. It'll pre-fill. Now let's just go ahead and run it as is. All righty. I'm going to pop this out in Zoom. You can see we now have overlapping density plots for each and every single sport. Now there's a couple of things that we can do to tweak our geom density ridge. Let's say we don't want these hills to overlap, right? Or we want to change the color. We might even want to add the medians on there so we can visualize medians for all these different distributions. Luckily, there's arguments within geom density ridges for us to adjust that. So on this next iteration, let's take a look at how we can add those details in. Same thing as the starter plot. We're going to use that mapping with the fem ath sub data set. And now within geometry density ridges gradient, we have different arguments to work with. Again, there's so many different things you can explore. Definitely encourage people to look at that HTML, that website link with more details. But for today, we're just going to adjust the height of the hill. So we're going to use scale. We're going to set it to 0.8. It's from a scale from 0 to 1. To show the median, we're going to plug in a Boolean argument here called quantile underscore lines. It defaults to false when we set it up. We're going to set it to true. And this will actually show you the different lines for all the 4 quartiles. But because we only want to look at median, we can adjust this by specifying which quantile line we want to see. So we're going to pick 2. And last but not least, this is another way of how we can suppress legends. So remember how we did legend.position equals none? In that one example, you can also hide a legend by using show.legend is equal false. Let's go ahead and run that all together and see what it looks like. Awesome. So now we can see no overlap with the different density plots. And we see now this black line that represents the median for each distribution. Okay. So we're going to do one more thing because we love reordering things in descending order, or by we, I really mean me, but hopefully there's other people who prefer viewing it the same way. We're going to now adjust this so it will descend based on the different medians per sport. And we're going to go through this real quick. So this is a data shaping problem. So we'll need to append the aggregate median for each sport to our original data set. So if you preview this FemAth sub data set, you'll see that it has each athlete with information on the athlete. But now we want another column that's going to give us the median weight for weightlifting, median weight for basketball, and each corresponding sport for athlete. We're going to use handy dandy dplyr to do a quick aggregation based on sport. Let's go ahead and run that piece of code. Great. And now I want to quickly take a look at joins. So another thing that you can do if you're working with 2 different data sets and you want to join them together, you can use left join, you can use inner join. We're going to do the same thing where you're using your data set and you're piping it together with a join argument. And the first thing that you're going to use is the data frame that you're appending. You have your first data frame here, and you're going to specify by. For us, it's the same column name, sport. Go ahead and click run. We now have one more data set called FemAth ordered. Now you can see at the very end, you have the median weight for each athlete. Promise that should be the end of dplyr for us today. That's the last transformation. And now we're going to apply reorder again to our data set. So we're reordering the sport based on median weight. Let's go ahead and run. Now we can see it's reordered. At the very top, you have basketball. At the very bottom, you have gymnastics. Now, taking a look at this density plot, I think one thing that we can call out is that there must be some pretty big outliers because it's trailing all the way past 300. So if we want to truncate this view, we can do that by calling another function with scales. So next iteration, let's go ahead and chop it off, and we can eyeball and say, I want to cut it off at 225, maybe the lower limit, set it to 50. The other thing that we'll do is we'll also look at playing around with colors. So the gradient that it's using default out of the box is a blue gradient. We can change that to another gradient using Viridis. So on building onto our density 2 plot, we're going to keep going with the plus sign. Now we're going to use scale underscore x underscore continuous. So because it's a continuous x-axis, we'll be using the scale. And the argument that we're going to be adjusting is limits. And we're passing to limits a list. And we're telling it, here's the lower limit and here's the top limit. So we're setting it to 50 and 225. And then last but not least, we're going to do some color magic with Viridis, and we're going to say scale underscore Viridis scale fill Viridis underscore C to adjust our continuous fill. Go ahead and run this. So now you should see a plot with a new gradient shade. You can see that the max is 225, min is 50. Go ahead and give me a thumbs up if you're seeing what I'm seeing. Cool. By the way, if you want to play around with different gradient options, there is an argument in Scale Fill Viridis where you can use different color palettes specific to the Viridis library. One of them is plasma, but we'll just use the default one. So if you prefer different ones, you can adjust it with option. Alrighty, almost there. So now we have a plot with the different medians for all of our different distributions. We have a new color palette. Labels aren't quite there yet, but we'll get there in just a minute. Let's say now for comparison, I want to compare it to the median overall for all athletes in this data set. One way that we can visualize this in our plot is perhaps by having an intersecting line going through this to call out the overall median. And an easy way to set up an intersecting line here, vertical one, is with another geom from our ggplot package called geom underscore v1, short for vertical line. The main argument that we're going to be using is setting the x-intercept, or where that line is going to intersect with. Here we can set up just an aggregation of our data set. I apologize, I didn't go over how to call different variables in our data set, but if you wanted to see a column variable for a data frame, you could use like the $ notation and then pass in, for instance, df $name. And then you could see just the name. So if I just wanted to see like the weight, I could pass that in and I could do something with it. I could aggregate, I could say sum, because there's NAs, I'm sure it's going to return an NA. Oh. Okay. So all we're doing here is using median to aggregate that data that we're using based on weight. We're setting the x-intercept to that median. And we can tweak the line, the type of line with line type. The default out of the box is going to give you a solid line. Let's go ahead and run that all together. Now we see this intersecting line right around, looks a little bit less than 150 here. Okay. So last but not least, we're now going to add our labels and our theme. For the sake of time, we're just going to run this chunk of code together. I invite all of you to change this section where it says chart name to your name specifically. And we can run it all together. And all we're doing here now is setting the labels. We're going to remove some of the panel grids. By the way, there's some out of the box themes that you can use with ggplot. We've been super custom by creating our own, but you can play around and you'll notice that there's different themes that you can use independently. Theme BW, theme classic. Theme minimal is going to remove a lot of the panel grid lines, so sometimes I default to that. Great, so now we have a cleaned up graph. We're going to take one more iteration of this graph to get a little bit more advanced with it, and that's by using annotations. So now we know what this graph represents because we built it together. We know what the black lines mean. We know it means these black lines over here mean median per sport. We know the dashed line here means median per overall. We might also want to add some context maybe to the data. So for instance, for judo and weightlifting, We can see it's multimodal, where you've got several different bumps along the way. If you take a deeper look at the data set, you'll actually notice that for weightlifting and judo, you have different weight classes. So if we want to tell our audience, by the way, it has different weight classes, and we want to guide them on what some of these lines mean, we can add annotations. And we can even add arrows to be specific about those annotations and what we're calling out. Real quick lesson on creating custom data frames. In R, you can set up your own data frame, just like you can create your own list, with a function called data.frame. And in this function, what you're going to be doing is you're going to be setting up your columns and all of the values that are going to be going into these columns. So I have a quick example here for us to take a look at. A hint on one of my favorite TV shows. I don't know if you can guess which TV show that is based on names, hopefully. So I've got data.frame, and the first name, I'm setting my first name column, and I'm passing a list of values. And I'm also passing a list of values here. It's important that the length of these lists are the same, or we will run into an error. Okay, so I have set up a custom data frame with our notes. And within that data frame, I'm including the X and Y coordinates for our graph, along with the accompanying text. I will say that setting up annotations for plots takes some trial and error. It's not always perfect. Sometimes I'll run it and it's a little bit too far to the left or too far up top, and I do a lot of adjusting. But for today, luckily I've done all that experimentation, so you don't have to. So we're going to go ahead and read in and create this custom notes data frame. All you need to know is it has our X and our Y, and it also has text, a text variable. So all I'm doing is I'm creating a note for our overall median. I'm creating a note for medians per sport. The other custom data frame that we're going to run right now is arrows. I don't expect all of you, by the way, to know how to build custom data frames, but please come back and revisit this later if you want. You can set up for our arrows data frame, we need a couple extra data points. We need to not only know the X and Y, but you want to know the starting point of that arrow, both for X and for Y. So here I've got an X start, X end, Y start, and Y end. We're going to be creating a few different arrows to accompany our text. Now, last but not least, let's get into how we can annotate our graphs. So the last density plot we have is density 5. I want us to go ahead and do that plus sign. And here's one way that we can annotate. Just like with our bar plots, you can use geom text. And this time, we can actually plug in a different data set. So instead of relying on that other data set, if we want to couple it with a new data set, we can use that data argument and say, use the notes data frame. We're going to say, go ahead and ignore all of the other aesthetics that I used for the other data frames. I'm going to do a new mapping. And now let's go ahead and map it to our new aesthetics for that data frame. So I'm saying X is equal to X because that's a column in my data set. Y is equal to Y. Label is equal to text. If you run this, I can see that it now has the text. It's a little too big, so we might adjust the text a little bit. And because I'm lazy with typing today, I'm going to go ahead and copy paste. Another way that we can annotate is by using an annotate layer. And I'm being really redundant. The way we can annotate is an annotate layer. I'm going to pass in text. And then the next thing that we can do is we can actually hard code our X and Y's. So we can say X is equal to 200. By the way, I know that our Y axis is discrete variables. You've got gymnastics and diving, but for the sake of plotting texts, you can actually use it as, you can convert it to like a continuous scale. So think of gymnastics as 1, diving is 2, and so forth. You can do 1.5 to specify this point in between. We're going to set the family again. And then you can set a label here and hard code that label as a string. Some of you might be wondering, well, what is this funky character here? We can use some basic HTML. I'm sure if you've done HTML before in the past, you're familiar that this indicates a line break. And we can use that in ggplot as well to indicate a line break. Okay, go ahead and run. So now we can see it's plotting our text, and it's plotting an additional line of text here because we're calling out a different distribution type for judo and weightlifting. All right, last but not least, I swear this is the light at the end of the tunnel. We're going to deal with adding arrows to be more specific. So we've got our text on our plot, but let's say now I want to specifically call out that median is this line or median's that line. Similarly, I want to do it for this dotted line. So we're guiding our audience or our readers to look at a specific point of our plot. We can use a geom called geom curve that will create curved arrows for us. And we're going to use that arrows data frame that we set up beforehand, pass it again as the data argument, and then set up our mapping. And the mapping for the aesthetic is a little bit different in the sense that you're not only setting up an X and Y, but you have additional arguments here for X end and Y end. It's pretty much saying, I'm going to start the line here, and then it's going to end up over here or end up over here. One more function, if we just plotted that without this arrow argument, we won't have like the arrowhead accompanying it. It'll just be a line. So if we want to actually create that arrowhead, you're going to pass an arrow. And here's a quick function to create the arrow. You can play around with sizes afterwards. Size represents the line thickness. Color is the color of the line. And curvature is just how much bend we're adding to the curve. So if you're doing a negative number, it's going to be an upwards curve. A positive number will be a downwards curve. And let's go ahead and run that all together. And there we go. There we have it. So now I have text for overall median. We've got arrows, and then we also have 2 more arrows for median by sport. It's pointing right to different median lines for diving and for swimming. And the final step, you want to save this to your computer. I'm going to use ggsave again, plug in the plot name, file name, width and height. And if you go to your, again, it might not be your desktop, it's whatever you set your working directory. So navigate to the working directory that you set up and click on, you should see a new file based on the file name you gave it in your directory. And there we have it. By the way, if you didn't change your name, I would definitely recommend you changing the name here at the bottom of the caption part. But that wraps up our session for plots. Go ahead and give me a thumbs up if you're able to see your plot in your working directory. Love my thumbs up peeps, thank you. And this is, I know we covered a lot of stuff today. Now you just have a working kind of cookbook to kind of come back to, play around with some things. Definitely welcome to watch this video again. If you're anything like me, I work best by learning by doing. I encourage all of you to check out Tidy Tuesday online. Every week they publish a new data set around like Monday night, Tuesday morning. And it's really cool because people share their code and it's a super supportive community. I remember doing my first plot thinking, oh God, that looks hideous. It was a standard scatter plot and I shared my code online, and the outpour of support from people saying awesome and teaching me new things like, did you think about doing this or that, is really cool. There's so many awesome people to learn from online. Would definitely recommend you engaging with them using hashtags like Tidy Tuesday, #RStats. I think Mansi and folks have links in the chat to explore later. If you want another challenge, there's also a cool one called the 30-day chart challenge, where they have a different prompt each day. I think yesterday was the part to a whole, today is pictograms. It's also a fun way of experimenting and using some of the stuff we learned today. That's all, folks. I know I talked a lot. I hope we learned some cool things together, and thank you for being a part of this. I had so much fun. I'm gonna open it back up to Mansi and moderators.
Yeah, so we just have one question in the Q&A panel, Q&A box, saying, can we apply the median to each of the graphs? I think it was quite early in the visualization process and I've lost context of it. Victor, can you please elaborate your question once so that Tanya can answer? Or Tanya, can you understand what they're trying to say? Can we apply the median to each of the graphs?
So applying median is into like to the bar plots. If we want to add a median layer, some context would definitely help. Sorry.
Yeah, exactly. Victor, we are waiting for you to just elaborate on your question once, and then Tanya can answer. And also, we're open to all kinds of questions now, since it's the end of the session. Please enter your questions in the Q&A box, and Tanya will take them. Also, thank you for the lovely feedback. If you have any other feedback, or if you're looking for any kind of help, please let us know in the chat box, questions in the Q&A box.
And even if you have questions later on, like let's say, tomorrow morning, you're wondering how do you create this with a bar plot? Feel free to reach out to me. If you use Twitter, I don't have a TikTok, but I do have a Twitter. Feel free to reach out to me on Twitter or on email. I'm happy to help. But asking questions is how we all learn together.
Yeah, and please join our Slack also, so that if you have keep a tab on our upcoming sessions, and if Tanya agrees, we can have another round 2 of the data visualization sometime soon. And you can also obviously participate in the 30-day chart challenge. It will be a good practice, and obviously you don't have to feel uncomfortable saying that it's basic or your charts are not as flashy, because you'll have to start somewhere, and we'll love to see all your data visualizations. Also, you can use this data that Tanya used and add something to it, tag us, tag Tanya, so that we can give you all a shout out. The session will be recorded and the event is uploaded to our YouTube channel, and our moderator has posted the link to our YouTube channel as well. Join our Slack and we'll post the link there as well. So I think we don't have any more questions, unless Victor wants to clarify their question. All right. Thank you, everyone. Thank you, Tanya, for doing this for us. And we had a lovely time together. And thank you for the great visualizations. And this is a definite, I'm sure most of us will enter the ggplot community soon.
I look forward to seeing a lot more ggplots from folks later on. Thank you again for your time. Hope you all have a great weekend.
You too, Tanya. Thank you to everyone who joined, and thank you to our moderators, and thank you to all our participants for making this session a great success. Bye, everyone.